Hey gang, so this is page 7, and we're going to continue on in our calculus unit. So on this one we've got tangent lines and the rate of change. So just kind of recapping what we were looking at the other day, we were talking about if we have a curve, what if we want to find the slope of the tangent line? And I was just looking, here's my little eraser, and remember we talked about this line right here being the secant line, the lines from P to Q. That was my secant line, and the tangent line was at P right here. And remember, it went across. And we said, if I want to know the slope of the tangent line, maybe I'll call that L, I would use the slope formula, right? I need to find the slope of this line. But the dilemma was I needed to have the point P, and I also had to find the point Q. So in today's lesson, we're going to look at the notation that calculus uses in order to find the slope of this tangent line. It's going to be a little bit different from anything you've seen, and we're going to use a lot of algebra. All right, so we're going to call this point right here, this is going to be x naught, or just our starting x. And then Q is going to be just a little bit on the other side of P, okay? So we're just going to call this distance h. Like if this was 1, maybe this is 1.00001. It's just a little bit beyond. Now on my picture, I'm going to show it so that it's quite a bit further just so I can see it. So let's say that P right here is the ordered pair. We would go over x naught and we would go up, and we're just going to call this f of x naught. Whatever the function is, we would evaluate it at x naught, and that would be that ordered pair. Q would be a little bit messier. It would be go over x naught plus h, and then you would go up, and the y value would be the function evaluated at x naught plus h. Okay, that would be my function notation. Here's what I know. I know, if you remember, the slope of the secant is the same as the slope of the tangent. Now, I know my picture, it doesn't look like that. But remember, we're going to move that Q so close to P that P and Q are almost the same thing, and the slope of the secant is the same as the slope of the tangent. So here's what we're going to end up getting. We're going to say that the slope of PQ equals. And here's what we're going to do. We're going to use our slope formula, and we're going to use this right here. We're going to come up with this little formula real quick. And so we're going to say y2 minus y1 over x2 minus x1. All right, let's plug this in. y2, so f of x naught plus h minus f of x naught over x2, which is x naught plus h, minus x1, which is x naught. Now, you're going to notice on the bottom down here, we've got x naught and a negative x naught. So we can actually cross those off, and we end up with, I'm going to try, I think I can write it over here. I'm going to try anyway. I'm going to end up with f of x naught plus h minus f of x naught, x naught, there's a minus in there, all over h. So the slope of PQ, actually I'm going to come down here and write it because it doesn't look good right there. The slope of PQ is f of x naught plus h minus f of x naught all over h. That's the slope of PQ, which I also know, oh, that's going to be smudgy. Sorry, y'all. Sorry, that got a little smudgy. That's the slope. So if I let Q be any point as it gets really, really close, so that this distance h right here, the distance from x naught to x naught plus h, so that h is just a tiny, it's like 0.00001. H is just a very small. Think of this as h approaches 0. Now I want you to kind of think about that. In other words, I'm taking this point, I'm moving it really, really close. As h is getting close to 0, again, we're talking about a limit. We're going to end up with a limit that's going to look like as h approaches 0. That's what this is going to look like as we go to find this slope. Okay, so we're going to take the same things we were doing the other day, and we're going to apply these same questions, but now we're going to look at it using this notation, which is the notation that you're going to be used to seeing as you enter into calculus in college if you take it. All right, so here we go. Find the equation of the tangent line to y equals x squared at the point 1, 1, which we already know it because we did it the other day. I think we remember it was 2. So here we go. So we've got f of x equals x squared. And so we've got the ordered pair 1, 1. So we're going to look at this as x naught and f of x naught. Whoops, there we go. I'll put it like that. So I'm going to come over here and I'm going to graph this like this. I'm going to put P right here, and I'm going to put Q. I always kind of label these because it kind of helps me whenever I do it. So P is 1, 1, and I think about what would Q be? Well, remember this is going to be x naught. So if I were to go out here just a little bit more, this would be x naught plus h. In this scenario, x naught is 1, x naught plus h would be 1, and then I would say plus a little bit more, right? So I've got 1 plus 1 here because this would be my f of x naught. And then over here, this would be f of x naught plus h. And so over here, I would have 1 plus h, and then I would have f of 1 plus h. Oh, I'm looking at it on the camera, it looks kind of funny, right? I'm going to put, this would be f of 1 plus h. Okay, so what I want to do, I was going to look at my notes because I started writing it a little bit different later on the other day, and I remember it really made it go a little bit better when I did it. So I've got x naught, f of x naught, and we said that was 1, 1, and then we've got x naught plus h and f of x naught plus h. Okay, so we know this is 1 plus h. We don't know f of x naught plus h. So what I'm going to do is I'm going to figure that one out. So f of x equals x squared. F of x naught plus h, right? Only I've got to put 1 plus h in there. So let me do that. I'm going to change that x naught because I already know what it is. I'm going to put 1 plus h is going to be 1 plus h. I'm replacing 1 plus h. This 1 plus h right here is going where x is, squared. I'm just substituting it in. Sorry, that doesn't look very good. 1 plus h. 1 plus h squared. So f of 1 plus h is 1 plus h times 1 plus h. Let's simplify that so we can see what goes over here. That'll be 1 plus 1, and I'll just go ahead and show it. 1 times h plus 1 times h, and h times h is h squared. That will be 1 plus 2h plus h squared. Right? And I don't think I guess I could kind of write it in here. I mean, it'd be kind of crazy to write it here. I'm going to actually write it like this, f of 1 plus h. I'm going to write it like that, f of 1 plus h. Okay, so here's what we know. From up above, we're going to say that the slope of PQ equals f of x naught plus h minus f of x naught all over h. Okay, we already know this right here. So f of x naught plus h, that's this one right here, x naught plus h. We just simplified it. So we're going to plug this one in here. So we're going to say 1 plus 2h plus h squared minus, we need to do f of x naught. F of x naught is right here. That's the 1. Minus 1 all over, and we're going to put h down here. Okay, let's see if we can simplify any of this. Okay, and so, and you know what, the only thing that I didn't put on this, I started doing my slope, right? But I forgot something. I'm going to put this on here. I really should have done this a little differently. When I put this here, I wrote it up here, and I didn't write it down here. When I go to find the slope of the tangent line, I didn't write it correctly. The slope of the tangent line is the limit as h approaches 0, and there's no equal sign in there. Let me fix my h. It didn't look. Ooh, ah. As h, oh, y'all, I should just start over. I'm not gonna. I'm gonna keep going. Oh, look at that whole smudge right there, y'all. Ah, his h approaches 0. Okay, there we go. So I'm gonna put that same thing down here. It's gonna be the limit as h approaches 0. The slope of the tangent line is this. So here we go. I can't put 0 in the denominator, right? So I'm going to see if I can clean this up a bit. So this is the limit as h approaches 0. 1 minus 1, let me get my red pen. 1 minus 1 will cancel out. So I'm going to have 2h plus h squared over h. Now, what I want to do is try and factor out those h's. See if there's any way to get rid of this denominator. So the limit as h approaches 0, I'm going to factor an h out. 2h plus 1. I did that backwards. If I factor an h out, that would be a 2 plus h right there. All over h. Factor out an h. Be left with 2 and left with h. Okay. H over h is going to cancel out. Now, from here, I end up with the limit as h approaches 0 of 2 plus h. Now tell me, can I plug 0 into this? Absolutely. So this would be, well, no, I'll keep it in black. This would be 2 plus 0. I can actually plug 0 in. What is 2 plus 0? It's 2. So what's the answer to the slope of the tangent? It's 2. And if you remember, we got that the other day when we did the same problem. So, look, I now know the slope of the tangent. The question was, though, find the equation of the tangent line. To find the equation, you need a point, which is 1, 1, and you need the slope of the tangent, which is 2. I now have both of those. So y minus 1 equals 2 times x minus 1. Y equals 2x minus 2, and I'm going to add 1 to both sides. So y equals 2x. Negative 2 plus 1 is negative 1. And there is, I'm going to dry that real quick. Maybe my marker won't smudge it all. Oh, nope, still going to smudge it all. I was trying to make it not. Okay, let's try another one. Number 10. And again, you can rewind that one if you need it. Find the equation of the tangent line to y equals 3 over x at the point 3, 1. Okay, so again, we are finding the equation of the tangent line. So if we're finding the equation of a line, we have two things that we need. One is we need a point, and the point that we have in this situation is 3, 1. The second thing we need is we need the slope of the tangent line, which we don't know. But we know the slope of the tangent line is the limit as h approaches 0 of f of x naught plus h minus f of x naught all over h. We know that. That's the formula that we have. So we just need to figure out, what can we do from this? So we know that f of x naught equals 3 over x. That's what we know. And we know that f of 3, if we plug in 3, our output is 1. So that means that x naught, f of x naught, is going to be 3, 1. Let's go with f of x naught plus h and f of x naught plus h. What would that be? Well, x naught is 3, right? So it's going to be 3 plus h. But then we need to figure out this one. So that would be f of 3 plus h. Can you figure that one out? I'm going to give you just another second. See if you can figure that one out. Okay. I'm going to come, I'm going to do it, actually I'm just going to do it right down here, I think. I'm going to say f of x naught plus h is going to equal f of 3 plus h, which is going to be, I'm going to go back to that equation, 3, right here, 3 over x, over, and everywhere I see an x, I'm going to put in 3 plus h. So it's 3 plus h. All right, so the f of x naught plus h is this. So here's what I've got. I've got the slope of the tangent line is the limit as h approaches 0. And I'm going to use this right here, f of x naught plus h. That's this right here. It's 3 over 3 plus h minus f of x naught. Well, f of x naught, in this case, is f of x naught, which is the y value, is 1. All over h. All right. I do need to simplify this some, right? So that's a whole lot of algebra. So what I'm going to do is I'm going to come over here. I don't want to keep having to write the limit while I try and simplify that. So I'm going to do this. I'm going to say the slope of the tangent line equals the limit as h approaches 0. And I'm going to come over here and I'm going to do this. 3 over 3 plus h minus. If I'm going to do 1 right here, I could put this as h over, well, the common denominator would be 3 plus h, wouldn't it? So I really need to say 3 plus h, right? So I would need to say this is 3 plus h over 3 plus h, right? And that way they're the same and I can put them together. And this would be over h. So on the top, it becomes 3 minus parentheses 3 plus h all over 3 plus h. Because now these are common denominators, and so now I can put those together. All over h. So on the top, this becomes 3, and I'm going to distribute that negative. 3 minus h over 3 plus h. 3 minus 3 cancels out, and I end up with negative h over 3 plus h. Now, this is all divided by h, right? So here's what I'm going to do. I'm going to come over here and say divided by h, because I'm getting tired of writing that. Now, if you remember your rules, when you divide by h, you really, it's like h over 1. Remember, you flip it and multiply. So I'm kind of running out of room, but in essence, I'm going to come over here. I would say negative h over 3 plus h, and I would say times, and I'm going to flip this and say 1 over h. Well, 1 over h, my h's are going to cancel out, and I end up with, I'm kind of going backwards here, negative 1 over 3 plus h. right? Okay, so this is just me simplifying all this. So once I simplified this crazy thing here, this is what I got. So when you simplify this, you get negative 1 over 3 plus h. So here's what we got. The slope of the tangent line is the limit as x approaches 0 of negative 1 over 3 plus h. Okay, so I can say this equals negative 1 over 3 plus, and I'm going to put it in red here, 0, because I can put the 0 there. Well, that means negative 1 over 3 plus 0 is negative 1/3. That means the slope of the tangent line is negative 1/3. Can I write the equation now? Yeah, because now I know the slope of the tangent line is negative 1/3. So y minus 1, and again, where am I going to get that 1? Sorry, that was really loud. Is this one right here. I'm using that point, and then I'm going to use this right here. So y minus 1 equals negative 1/3 times x minus 3. So y equals negative 1/3 x plus 1. The 3's would cancel. And then I'm going to add 1 to both sides. So y equals negative 1/3 x plus 2. And there's that. Okay. Now, how important is it to know how to do this? It's not like super important that we know how to do this, but it is worth knowing that you've at least seen this, because you will see this in your calculus days as you get there. For this one, I'm going to get you started on this one on the video. In class, I'm not sure if we're going to do this one, but I'm going to go ahead and get you started. So, find the slope of the tangent line to y equals the square root of x at any point. Oh, I forgot this one's at any point. Okay, so these other ones that we did, they were at specific points, right? 3, 1, 1, 1. What if I wanted to know at any point? Like, could we do that? Absolutely. So the slope of the tangent line, we know it is the limit as h approaches 0 of f of x naught plus h minus f of x naught all over h. We know that's the formula. That's what we have to use. We know that f of x naught in this scenario is the square root of x, right? Which means that we have the ordered pair x comma the square root of x. That's what our x naught and f of x naught is. Like that's our first one. Then the other thing, I kind of wrote those backwards. The other thing we have to know is what is x naught plus h and f of x naught plus h. Okay, well, that would be x naught plus h. So here's x, so it actually is just going to be x naught plus h. But when you do f of x naught, it's going to look a little bit different, right? Wouldn't it just be, since it's the square root of x, we'll just say x naught plus h underneath the radical. That was actually not too bad, right? So here's, I'm going to highlight those. Even though I put them backwards. Here is the one point. Here is the other point. So let's see if we can do this. Let's do the slope of the tangent equals the limit as h approaches 0 of, and we're going to do the square root of x naught plus h minus the square root of x all over h, right? And at first glance, when you look at that, you're like, oh, okay, well, Well, remember the whole point behind this when you go to take the limit is if you put 0 in, it like does something. But when you get to this one, oh, and that should have a naught under it. When you put 0 in, like you don't really get anywhere with this one. Like you don't get an answer on this one because it doesn't work out. Because 0's in the denominator and you can't have a 0 in the denominator, right? It doesn't work out. So you have to use some of your algebra skills. And you have to multiply, if you remember, by the conjugate. So what we're going to do, and I'm just going to kind of help you remember, is you want to multiply by what we call a well-chosen number 1. something that doesn't change the problem. I want to try and get rid of these radicals. So what I'm going to multiply is x naught plus h, and then I'm going to say plus the square root of x naught. And if I multiply by this, put it over here. If I have the exact same thing over the exact same thing, that's what I call a well-chosen number one. Like these would simplify, this right here simplifies to the number one. It's like I'm taking this and multiplying it by the number one. I haven't changed it at all. So it's called a well-chosen one. But when I go to simplify this, it's going to do some magical things to my problem. So here we go. I'm going to say this is the limit as h approaches 0. Now, we're going to be real careful. When you multiply this, it's like the difference. The middle term's going to go away, right? So here's what's going to end up happening on this. Basically, you're going to get rid of the radicals, and you're going to end up with this. You're going to end up with x naught plus h here, because you're going to have these. Your middle terms, because one's going to be positive and one's going to be negative, your middle terms are going to cancel out. And then, you're going to have minus, and you're going to end up with x naught. Okay. Oh, I put x. That looks like it's to the 0 power. That naught should be on the bottom. But then on the bottom, and now I'm going to be real careful on this. It's h times this. Don't multiply that out. Do me a favor and just keep that written like this. And the reason why is because remember, we're trying to get rid of the h. And so hopefully that h is like going to go away or something here in a minute. All right. H naught and h, or not h, x naught and x naught. Those are going to cancel out, right? So here's what we've got. We've got the limit as h approaches 0 of h over the square root of x naught plus h plus the square root of x naught. You know what? Let's do this too while we're doing that, because I bet y'all are okay with this. There's an h up here. I'm going to do it in a different color, and an h down here. Are you okay that once we cancel those out, if we go ahead and cross those out, and we end up just with a 1 up there on top? Like, can we do both of those in that one step? Okay. Well, what happens now if I go ahead, can I plug 0 in now? Because now I don't get 0 in the denominator. So what happens if I actually plug in the 0 now? So let's do, here we go, the slope of the tangent. And then once we plug in the 0, we can lose the limit. So it would be 1 over the square root of x naught plus, and I'm going to put that 0 right here, plus the square root of x naught. And I'm going to keep going. And that's going to be 1 over the square root of x and the square root of x. That's 2 square roots of x. So that means the slope of the tangent line equals 1 over 2 square roots of x. And that's for any slope of any tangent line. No matter where the point is on the graph, it won't let me stop my video. The slope anywhere on the graph, that is the slope. And it works anywhere. Anywhere I want to find that. And that is the beauty of calculus. Okay, so let's find, let's write the tangent line. Let's write the tangent line at the point, let's do the point, let's say 1, 1. 1, 1. Let me zoom this out a little bit. So at the point 1, 1, what would the slope be? Okay. Write the tangent line at the point 1, 1. So we would plug x in here. So if we plug 1 in here, that'd be 1 over 2, square root of 1. That'd be 1/2, right? So that means my slope would be 1/2. So I would do y minus 1 equals 1/2 times x minus 1. I would simplify that to y equals 1/2 x plus 1/2. There we go. And it works for anyone. And that's what's really cool. I'm going to put here on my notes for any. I wasn't planning to work that one, y'all, but I ended up working it. That is for any point on the line y equals the square root of x. All right, average velocity and instantaneous velocity. So velocity, average velocity is how far you've gone divided by how long you took to get there. Think about it, displacement over time. All of you have had physics, so you guys kind of know that. So let's just write that down. Let's put how far you've gone, how far you have gone divided by how long it took you to get there. It took you to get there. Or we could just say displacement over time. Okay. Now, this goes into a whole lot of stuff here, and it's pretty much the same thing. Okay. And we're going to just look at it, and I'm going to show it to you, but it's going to end up being the same thing. So what we're going to look at is we're going to look at this as a function of time. So we're going to say f of t naught plus h minus f of t. Okay. I should have put t naught. And then we're going to say divided by, since it's a function of t, we're still going to say divided by h. H is going to be, I'm going to put this right here, h is going to be our time traveled. Let's see. F, the function's going to give you the position after a little while. This f, the t naught plus h, that's going to be like after you've been going for just a little while. And this one right here is going to be at the start, like your starting position. I'll say starting position. And then this one would be after just a few seconds. Or after a few, just after a bit. I'll put a bit. That'll be kind of the easiest way to look at that. All right. So in this particular problem, we've got this function, s of t, right here, s of t. And we're doing over the interval from 1 to 3. Okay? So our starting time is 1 and our ending time is 3. So I'm going to think about it like this. T naught, our starting time is going to be 1. Okay. When I think about the time traveled, how much time did I travel? So what is my h going to be? How much time lapsed? I went from the interval from 1 to 3. So h is going to actually be 2. And some of you might be, well, wait, it's 3. No. I went from 1 to, it's the velocity. I went from 1 to 3. So the actual time traveled was like 2 seconds, from 1 second to 2 seconds, 3 seconds. Oh my gosh, I can't say that. I'm going to say it like this. Time elapsed. Okay. Let's put this here. How much, this was probably the hardest part when I was learning this the first time, was trying to figure out what h was, and I had to just really teach myself that it's the time, it's the elapsed time when you're doing velocity. Time elapsed. How much time went by? So this is 3 minus 1, which is 2 seconds in this scenario. All right, so let's figure out what is s of 3. So let's just plug it in. So that'd be 1 plus 3 of t of, yeah, however I want to say that, minus 2, and then we're going to plug in 3 squared. And then we're going to find s of 1. 1 plus 3 times 1 minus 2 times 1 squared. All right, I'm going to grab a calculator real quick. Now, in essence of time, to keep the video going, I got -8 here, and I got 2 here. I am going to check that. That seems odd that I got a negative number, so I just want to check that real quick. So 1 plus 9, yeah, that will be negative, minus 2 times 9. Yep, -8. Oh, -8 right there. All right. So, what do we want to do? We're trying to find the average velocity. So here's what we know. Velocity average. it's going to be S of T naught plus H in this scenario minus S of T naught all over H. All right, well, in this scenario, we take S of 3 minus S of 1 divided by H. So we're going to take S of 3 minus S of 1 all over 2, or I'm going to put H, sorry. So S of 3 was negative 8 minus 2 all over 2. So that's negative 10 over 2. So the average velocity, it's slowing down obviously, is negative 5. There it is. Now, on this particular one, if I wanted to know, I guess I could say the slope. I'm going to put it here in the middle. I didn't leave myself much room. But if I wanted to know the slope, the change in y over the change in x on this interval from 1 to 3, here's kind of an interesting thing to think about. If I wanted to know the slope, if I plugged in 1 and I plugged in 3, okay? If I plugged in 1 into my equation, which is what I did down here, I got 2. So the order of pair was 1, 2. And then when I plugged in 3, I got negative 8. So I have these two ordered pairs, right? So the slope of the tangent, that's what I'm really finding here, right? If I were to use this ordered pair right here and find the slope of the line, you know what? It would be the same thing. It would be negative 8 minus 2, y2 minus y1 over 3 minus 1, which is negative 10 over 2, which is negative 5. So your average velocity is the slope over the interval evaluated at that. I do believe, actually I don't remember if that formula is in your chart or not, but anyway, you can kind of look at that. All right, so I'm going to keep going. So now we've got instantaneous velocity as well. Oh, where is that? How much time elapses in an instant? So average velocity is over time. How much time elapses in an instant? And time has to elapse, otherwise we'd be stuck in the same spot for forever. So I'm going to say average velocity is over a period of time. So is over a period of time. Just like we just did. It was those 2 seconds we were taking the average velocity. But what if I want to know something at that exact instant? At that exact instant, something falls. Find the instantaneous velocity at 5 seconds. Exactly at 5 seconds, how fast is it going? Now the stakes have changed. Now we've got a different scenario. Now we've got a limit. I need to know as I come in from the left and I come at the right, what's that instantaneous velocity? So now I can't just find the slope. I've got to do a limit. So we're going to call this velocity instantaneous. Okay, and we're just going to do a limit. We're just going to say the limit as h approaches 0, and we're going to do it, and we're just going to use our t naught plus h minus f of t naught all over h. So let's see if we can figure this out, right? So s of t in this situation is 500 minus 16t squared, right? All right, so we're starting our t naught. What's our starting time? Like, what are we starting this at? Well, our t naught is 5. Okay, so that means I need to know f of t naught, which means I need to know f of 5. Or I guess I switched from I switched from f's to s's, didn't I? Okay, are y'all okay if I actually take my s right here? I'm going to change that to an f because, look, I went to f's, and so know that my s right here, I'm going to put it right here, I'm going to put an f. You can keep it S's if you want. I slipped into the F. Okay, so F of 5. So let's plug that in. So that's 500 minus 16 times 5 squared, which comes out to be 100. So I have the ordered pair. If you plug in 5, you get 100. So that means this is T naught and F of T naught. And also, I seem to have this problem with capital letter T and lowercase letter t. I'm going to try and keep them all lowercases. Oh my gosh, y'all. Okay, I am going to highlight that though. So, here's the first one. Now I need to do F of T naught plus H. Okay, so I need to take T naught. Let's, I'll put it down here. So T naught plus H and F of T naught plus H, right? That's the other one I have to have. T naught plus H. Would that, are y'all good if I just say that's 5 plus H? Because that's T naught plus H. And then I need F of T naught. So I need to go into this function. Oh, yuck. I got to go into here and I got to put T naught plus H. Oh, yuck. That's going to be a hot mess. So here we go. 500 minus, parenthesis, let's see, 16 times 5 plus H squared, right? Here's my X. I got to plug it into there. Okay. I need to simplify that, don't I? So I'm going to come right here and I'm going to see if I can simplify that. So I'm going to say equals 500 minus 16, 5 plus H squared. So that's 5 plus H times 5 plus H. And I'm gonna write it just like that. So that's 500 minus 16. Here we go. 5 times 5 is 25. Plus 5H and 5H. Are you okay if I do that in my head? 5H and 5H give me 10H. And then H times H will be H squared. Okay, so that's 500. And now I need to multiply that. So I'm going to have 16 times 25 minus 400. 16 times 10 will be minus 160H. And then 16 times H squared will be minus 16H squared. All right. 500 minus 400 will be 100 minus 160H minus 16H squared. Okay. So I'm feeling pretty good right there. I feel like my F of T naught plus H, there's that. So now I'm going to take this and now I'm going to come over here and do my limit. All right, so here we go. The limit as H approaches 0. And we want to do, we're going to do this one right here. F of T naught plus H. So that's what this was right here. So we're going to say 100 minus 160H minus 16H squared minus F of T, which was in this case, F of T was 100. Okay, all over H. All right, one more. The limit as H approaches 0. Okay, let's see what we can put together. 100 and 100 are going to go away. So that's going to give me, and on this one, I'm going to go ahead and factor out the H. I'm not going to worry about the 160 and the 16 and doing anything there. I really just want to take that H out and leave me with negative 160 minus 16 and then keep that other H right there. All over H. And the reason why is because my whole point to do this is I want to get rid of those H's. I want them to cancel out. Those are going to cancel out. So I end up with the limit as h approaches 0 of negative 160 minus 16h. Can I plug in 0? Yes, I can. So when I plug in 0, I end up getting negative 160 minus 16 times 0, which is negative 160. So that means that the instantaneous velocity, instantaneous, is negative 160. I was down there right and you couldn't even see it. Okay, same problem. What if I don't give you a specific second? Same problem. What if I say at any second? And this is the one where the calculus comes in. Like the other one up there, yeah, I mean, that's really just physics. You could have figured that out. But this is where the IB math and the calculus comes in. What if I want to know at any specific time? Like I want to be able to say at 5 seconds, at 3 seconds. What about at 2.3 seconds? Could you tell me the answer then? Okay, so we're going to do that same problem. S of t, I'm going to try and do it with s's this time, is 500 minus 16t squared. And we're going to do any second. And then we're going to do s of t naught plus h would be 500 minus 16 times t naught plus h squared, right? Let's see if we can simplify that. That would be 500 minus 16 times t naught plus h times t naught plus h. Let's go again. 500 minus 16 t naught squared plus 2 t naught h plus h squared. Oh, I put the squared in the wrong spot. Squared. If you are an algebra guru right now, you're like nerding out. You're like, oh my gosh, this is so fun. Okay, here we go. Equals 500 minus 16 t naught squared minus 32 t naught h minus 16h squared. So here we go. S of t naught plus h. And I'm going to box that in because that's a pretty important thing to have. I'm going to box this one in because I need that one too. Now what else do I need? I really don't need anything else but h, right? Okay, so here we go. The limit as h approaches 0. We're trying to find the instantaneous velocity at any second. It's going to be s of t naught plus h. Oh, I need to keep it s. Minus s of t naught all over h. That's the formula I want to use. So it's the limit as h approaches 0. 500 minus 16 t naught squared minus 32 t naught h minus 16h squared minus parenthesis. And then I need to go back up here and do 500 minus 16t squared. All over h. Okay. Keep going. I'm going to go ahead and write it one more time. Minus 500 plus 16t squared all over h. I'm going to look and see what can I mark off. All right. Positive 16 t naught squared. Those are going to go away. Positive 500s are going to go away. All right, so that's going to leave me with the limit as h approaches 0. I'm going to move this up just a little bit. This negative 32 T naught h and negative 16, I'm going to go ahead and factor that h out to the front because I know I'm going to end up with h over h. I'm going to have negative 32 T naught minus 16, and I'm still going to have an h in there. All right, so that means my h's are going to cancel out. And what that's going to do now, my h's are gone. I'm going to go ahead and say negative 32 T naught minus 16, and I'm going to plug in that 0. I'm going to actually take the limit now. So that means it's negative 32 times T naught, whatever the initial value is, right? Whatever time you're starting at, that's going to be your velocity. Okay, we are going to check this. That's pretty awesome that you just found that. Like for any problem that's going to work. Okay, let's check it. Okay, so we're going to come up here. We're going to check this puppy out. Here we go. Negative 32 T naught, that is, and I'm going to put it right here. We just figured out that the instantaneous, I have to write this out, instantaneous velocity for any point, any second, is negative 32 T naught. Now we're going to check it. We want to check what if we do at 5 seconds, right? Because we got negative 160. Let's check it. What is negative 32? I can't write today. Those of you that are faster than me, you've already checked it. Negative 32 times 5. What is negative 32 times 5? Negative 32 times 5. Bam! Negative 160. And it worked. Instantaneous velocity at any point. Yeah, it's pretty awesome how that works. All right, we're at 52 minutes. We're going to keep rocking and rolling. I hope in class we're able to go a little bit faster than this, but we'll see. All right, slope, rate of change. We already know all this, slope and rate of change. Let's see. We know that the slope y equals 3x minus 1. We know that the slope in this situation would be 3. The rate of change, I'm writing a little fast here. Rate of change, we know our formulas, y2 minus y1 over x2 minus x1. In calculus, the slope of a curve at a point, is the instantaneous rate of change. We know this as the rate, the average rate. We call it f of x naught plus h minus f of x naught all over h. The instantaneous rate, we call it instantaneous. We call that the limit as h approaches 0 of f of x naught plus h minus f of x all over h. Instantaneous rate or the average rate. We can do it either way we want to look at it. We can look at it as a limit, or sometimes we can look at it just as the function notation. So find the average and the instantaneous rates of change of this curve. Okay, so for the average, what we're going to do, we're going to do it over an interval. I forgot to put these in your notes. The interval we're going to look at is from 2 to 5. For the instantaneous, we are going to look at x equals negative 2. Those are the two spots I want to look at. Okay. So for the average, let's just using this function here. Let me highlight it so I can find it a little faster. And I'm sure in class I probably had you guys just do these on your own. I probably did not work them with you. All right, so we're going to say x naught on this first one is 2. And we'll say x naught plus h, x naught plus a little bit, would be what is h going to be? Remember, we're going to have to look at the distance here. How much time elapsed? Well, we would do from 2 to 5, which is 3. That means we're going from x naught, which is 2, plus how much would h be? H would be 3. So 2 plus h. And in this case, this would be 2 plus 3 is 5. Okay, so you got to kind of think about it like that. So remember that, also you can remember we could just do those points. Remember how we just found the slope and we did it that way? You could also just do it that way. It might actually be easier to do it that way. I don't know. All right, so let's do the average velocity. All right, so let's do f of 3. Oh, nope, not 3, f of 5. Sorry. F of 5 minus f of 2 over h, which in this case we said was 3. And this was what we called the average. So I'm going to come over here. 3x squared minus 4. So 3 parentheses 5 parentheses squared minus 4 is 71. Minus, 3 parentheses 2 squared minus 4 is 8. Divided by 3. Is 21. Okay, I got 12. Oh, no, I didn't. I got 21. Okay. Ugh. So there's my average rate. All right, so now let's look at the instantaneous at -2. So for instantaneous, we're going to have to do a limit. So for instantaneous, let's look at, we've got x naught, right? X naught was 2. And then let's look at f of x naught plus h. So this is going to be, we're going to go back to our equation, but we want instantaneous. So we're going to do 3 times x naught plus h squared minus 4. So that's going to be 3 times x naught plus h times x naught plus h minus 4. 3 times x naught squared plus 2x naught h plus h squared minus 4. I'm going to go ahead and multiply everything by 3 and get 3x squared plus 6x naught h plus 3h squared plus 4. Or minus 4. Oh, I changed my minus 4 to a plus 4. Let me change that back to a minus 4. Minus 4. Okay, so let's do the limit as h approaches 0. And we need to do f of x naught plus h. So we're going to do 3x squared plus 6x naught. I keep always trying to put those at the top. H plus 3h squared minus 4 minus, and then I'm going to do x naught, which is 3x squared minus 4. All over h. All right, limit as h approaches 0. 3x squared plus 3h squared minus 4 minus 3x naught squared plus 4 all over h. Let's see what marks off. Okay, the 3x squareds are gone. The 4s are going to be gone. So I'm going to get the limit as h approaches 0 of 6x naught h plus 3h squared all over h. So the limit as h approaches 0, we're going to factor out that h times 6x naught plus 3h all over h. The h's will cancel out, and we can plug in the 0. So we're going to end up with 6x naught. 3 times 0 would be 0, so it'll be 6x naught. So at any given moment in time, the instantaneous velocity would be 6x naught. So if I want to know at -2, I would do 6 times -2. That would be 12. So let's say the instantaneous velocity is 6x naught. And we could, so at x equals, I kind of remember, x equals -2, velocity would equal -12. I'll just put it in there like that. All right. So we're almost to the part that we've been trying to get to on this, which is what's going on here. Like, we keep taking these limits, we keep finding these rates of change, we keep finding these slopes. We've gone through a whole mess of stuff here with all these curves, moving this down, finding these limits, using this function notation, f of x naught plus h minus f of x naught over h. We've used it over and over. It just seems like we're constantly finding the slope of the tangent line. And what we are, in essence, finding is a word that I don't know if you've had it before, but this is what it is. When you are finding the limit as h approaches 0 of f of x naught plus h minus f of x naught over h, you are finding a derivative. It has a name. We haven't called it that yet, but that's what it's called. It is called a derivative. We used the derivative to find the slope of a curve at a point. Now, here's what you need to know. And from here on out, it's so much easier. We use the formula to find the slope of the curve at the point. Like this right here, highlight that. Man, that's like the gold. That's the gold of everything you've done up until now. That's the big part. We use the derivative to find the slope of a curve at a point. So when I say find the instantaneous, I hate writing this because I can never spell okay, I have to cheat. Where did it go? Oh, there, instantaneous. Okay, when I said find the instantaneous velocity, that's finding the derivative. Okay, when I said find the instantaneous rate of change, oh, that's the derivative. When I said find the slope of a curve at a point, oh, that's the derivative. When I said find the equation of a tangent, here we go. Find the equation of a tangent line by finding the slope of a curve at a point. Oh, that's the derivative. So you are now able to say, anytime I want to find any of that, oh, Miss Dean, you just want to find the derivative. And now that you know that, the rest of it is mind-blowingly easy. Okay, for derivatives, from here on out, like I said, it's about to get a whole lot easier. we have function notation. I'm not going to use that. I'm going to use the red. Function notation you know as f of x. That equals a function. Okay. Here's what you're going to say for the derivative, because we've been writing out the limit as x. We don't want to keep writing that out. Now when we're writing a derivative, we want to have a shortcut way to write it. You're going to put a little tick mark up there like that, and it's called the derivative. You read it as f prime of x. That's how you read it, f prime of x. Now, sometimes you will write it like this, y prime. Sometimes you will write it as dy dx. In college, it seems like a lot of times I called it dy dx. Sometimes you will see d dx, the derivative with respect to x. There is one other way that you might see it. It is f with a little -1 up there of x. That is not f inverse. That's the derivative. Read the context of the problem to know which way they're asking it. Last year, in the IB exam booklet, they asked the problem, and it said, find the derivative of the function, and they wrote it like this, but if you read it, you knew that they were asking for the derivative when they came down here and asked for it. And it stumped a lot of students. So anyway, a lot of people thought they were asking for the inverse, and a lot of students missed that problem. All right, so here's what we're going to do. We're going to take this problem, f of x equals 2x to the second power minus 3. And so what we want to do is we want to say find f prime of x equals the limit as h approaches 0. And we're going to say of f of x plus h minus f of x all over h. Now, I did drop the knots on this one just because I wanted it to be easier. So here's what we know. We know that f of x is 2x squared minus 3, and f of x plus h, because that's the only other one I need to have, would be 2 times x plus h squared minus 3. And I'd go ahead and I would simplify this. And I'm going to go ahead and save you some time here because I've already done it. And this is what I got. I got 2x squared plus 4xh plus 2h squared minus 3. Okay. And it seems like on this one, oh, that was a different part. All right, so here we go. We're going to take the limit, and I'll move my paper here in just a second, as h approaches 0. So I'm going to take this one, and I did not leave myself enough room, but it's going to be 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared minus 3 all over h. Okay, then I'm going to say the limit as h approaches 0. Now, I'm going to cross some things off because I know that I'm going to change the sign on these two, and I know those 2's are going to cancel out. This -3 is going to become a +3, and when I do, those 3's are going to cancel out. So what's going to end up happening is I'm going to have 4xh plus 2h squared all over h, and so that's going to leave me with the limit as h approaches 0. I'm going to have an h out here with a 4x here plus 2h here all over h. My h's will cancel out, and I'll end up with the limit as h approaches 0 of 4x plus 2h. And I would put the 0 in, and I would end up with just 4x. So at any point, I know that the derivative is 4x, meaning the slope of the curve at any point is 4x. So I would say that f prime of x is 4x. That's what I need to know. The slope of the curve is 4x. The derivative is 4x. So you want to know, find the equation of the tangent line at 2, 5. Well, here's what I know. I know the point is 2, 5, and I want to know the slope. Well, I take the derivative. I find the derivative. Here's the derivative. It's 4x. If I want to know the slope of the point at 2, 5, I simply plug 2, that's the x value, into the derivative. So I say f prime of 2 is 4 times 2. Okay, that's 8. That means the slope of the line is 8. Once you know that derivative, bam, you can find the slope. Okay, so that's y minus 5 equals the slope times x minus 2. Y equals 8x minus, let's see, that'll be negative 16. Negative 16 plus 5 will be 11. So what's the equation of the line? There it is right there. Now, we are almost done. I know this has been a really long video. If you've stuck with me for the hour and 10 minutes, kudos to you. Y'all ready to learn a shorter way to find these derivatives? I took you through this because you really, really need to know how to do that. But it is almost time, y'all, to take it home and do the last one. This is the last one I'm going to make you do this way. After this one, yeah. And if you're in class doing this with me, I made you do this one on your own. So here it is. Last one. Find f prime of x. So in other words, find the limit as x approaches 0 of f of x plus h minus f of x over h. Can you do it? Here we go. F of x equals 2x to the third minus x. F of x plus h. I'm going to leave the knots off because sometimes when I get the knots on here, they end up getting messy. 2 of x plus h cubed minus, oh yeah, x plus h. Yuck. All right, we have to simplify this. So, 2, this is going to be x plus h times x plus h times x plus h minus x plus h. Now, that is just a whole lot of algebra. And I know that you can work that in your head. I'm going to move down. I'm going to give you some time to work it. But if you work it, here's what I got. I ended up 2 times, I got x to the third plus 3x squared h plus 3xh squared plus h to the third minus, and then I have x plus h. Once I multiplied, that mess out. All right, then I took the 2 across, and then I'm going to go ahead and get rid of that. So it ended up looking something like this. 2x to the third plus 6x squared h plus 6xh squared plus 2h cubed minus x minus h. And then from here, after I did that, I had all my equations ready. And I'm going to put this right here. And then from there, I did this. Okay, the limit as h approaches 0. 2x to the third plus 6x squared h plus 6xh squared plus 2h to the third minus x minus h minus 2x to the third minus x. All over h. All right, now again, I know that this is going to become a minus and a positive. So 2x to the third is going to cancel out. Positive x and negative x are going to cancel out. So I'm going to end up with the limit as h approaches 0. 6x squared h plus 6xh squared plus 2h cubed minus h all over h. So I'm going to try and factor out an h. So it'll be 6x squared plus 6xh plus 2h squared minus 1 all over h. Now the h's are going to cancel out. So I'm going to get the limit as h approaches 0. 6x squared plus 6xh plus 2h squared minus 1. So here's what's going to happen. When I plug 0 in, 6x squared plus 6x that's going to be a 0, plus 2, that's going to be a 0, minus 1, which is going to end up being 6x squared minus 1. So that means f prime of x, the derivative, is going to be this right here. Now I know that was fast. It's a video. You can always slow it down, you can always pause it, you can always rewind it. Alright, so there's my derivative. Let's get to these rules. Here we go. What is a derivative? Oh my gosh, it's the slope of the curve. It's the slope of the line. Oh my gosh, I can't even say it now. I just drew a blank. It's the slope of the curve. The slope of the curve at a point. Okay? That's my derivative. And now you know how to find it. The slope of the curve at a point. At any point. No matter where we are, we can find it. Here's your rules. And I'm going to use d dx. If you have d dx, x to the n power, here's the way it's going to work. You are simply, if you have a derivative, you are going to take this number, this exponent, you're going to put it in the front. You are going to multiply you're going to bring the n to the front, and you're going to decrease the number by 1. That's all you're going to do for that. So let me give you an example. And we didn't really talk about it just then in the video because I was going so fast. I wanted to get it done. But let me give an example. So if I'm do the derivative of x squared, the exponent is 2. I bring it to the front. I take the 2 and I reduce it by 1. So that means the derivative is 2x. 2 minus 1 is 1. There's the derivative. Oh, you're already like, what? And you didn't have to do the limit. I could have done the limit of x squared and then f of x. Yeah, already you're like, oh my gosh, what? Yes, you can do this every time and it works. Here we go, x to the 5th. I'm going to bring the 5 to the front, x to the 4th. Oh, you know what? Let's do this. You can go ahead and just box it in. I want to go ahead and put it on my notes. I want to put one more example where I brought it all the way out. I'm going to go ahead and say 5x to the 5 minus 1, and then I want to say 5x to the 4th. I just want to have that extra step in there for you. Okay, let me do d ds. So again, you could have a different variable in there. S to the 15th power. Okay, well, I would bring the 15 to the front. We put this to the 15 minus 1. That would be 15 to the s to the 14th power. Okay, oh, you know what? That kind of looks like 100, doesn't it? I guess s's and 5 shouldn't go together. Okay. Let's do another one. Let's do x to the negative 3. Same rules apply. Bring that negative 3 to the front. X to the negative 3 minus 1. So that's negative 3x to the negative 4th power. I'm not going to move the negative 4 to the denominator. I'm just going to leave it right there like that. All right, last one, d dx. Let's do x to the negative 1. Bring the negative 1 to the front, x to the negative 1 minus 1. So that's negative 1x to the negative 2 power. Again, I could have done the limit on each one of those and taken about a half a page to do it, but yeah, it wouldn't. It would have taken half the page. All right, I actually have one more, sorry. X to the 0 power. All right. Oh, sorry, not x to the 0, just x. All right, so this is like to the 1, so you would bring the 1 to the front. It would be x to the 1 minus 1, which is 1 times x to the 0 power. Anything to the 0 power is 1, right? So this is like 1 times 1, so it would just be the number 1. All right. Now we have, what if you have a number in the front and then the function? Okay. We're going to do this. Oh, you know what? And also on this, I meant to do this. I'm going to highlight the rule on this just so I have it a little bit easier to see. So on this, the rule is that I'm going to bring the constant to the front, and then I'm going to take the derivative of the function. So I'm going to do the derivative of 5x to the 4th. So here's what it's going to look like. I'm going to take 5, and then I'm going to do d dx of x to the 4th, just like what I just did a second ago. Sorry, that got a little crooked. So that's like taking 5 times, well, let's do 4x to the 4th, right? So that would be 4x to the 3rd power. 5 times 4 would be 20x to the 3rd power. Okay. Do you get the idea that you really could just have said 5 times 4? So let's try that again. Let's try negative 1x to the 7th power. And on this one, let's try it a little shorter. I could just say 7 times negative 1. That would be negative 7x to the 6th power. And you're getting the idea. It's pretty straightforward. Okay, so d dx. What if I had pi over x squared? Now, before you can work this one, you can't take the 2. It doesn't work if it's in the denominator. You have to rewrite this as the derivative of pi x to the negative 2. You have to bring those exponents up to the top. Even though they're negative, like this is reverse of everything you've ever been taught about exponents, and then you work it. So it's negative 2 pi x to the negative 3 power. I mean, it's like seriously the reverse of everything you've learned about exponents in your life. You're like, wait, exponents are supposed to stay. They're not supposed to be moved around when they're negative. I know. It's super like confusing at first. All right. What if we have where we're going to be adding and subtracting? What we're going to do is we're going to take the derivative, and you're probably already thinking it. We'll take the derivative of the first, and then we'll add or subtract, and then we'll take the derivative of the other one, and we'll just add them together. Okay, so here we go. Let's do an example. Let's take the derivative of 3x to the 9th minus, we'll do x to the negative 3rd. So let's say, let me give you that. Now I'm going to write this out, and just bear with me, because once we write it out once, you won't ever have to do this again. So this is where we take the derivative, and we do 3x to the 9th. In this scenario, we were subtracting, so we'll say minus the derivative of x to the negative 3. And so we'll just do it term by term. So that means this is 9 times 3 is 27x to the 8th. Minus, this will be negative 3x to the negative 4th. And then we'll simplify it a little bit. 27x to the 8th plus 3x to the negative 4th. And I'm just going to leave it right there like that. All right, let's do one more. Let's do the derivative with respect to x. 6x minus 4x to the 3rd over 2x. I'm going to let you look at that one for just a second. On this one, what I want to do is, before I even start, I'm going to simplify this. I'm going to say 2x goes into 6x, 3x. Actually, sorry, I'm not even doing my math right, am I? I'm going to do it like this. 6x over 2x minus 4x to the third over 2x. I'm going to look at it like that. And then I'm going to do this. I'm going to say that's 3 minus 2x squared. And then I'm going to say, okay, now I can do the derivative. But you're like, but how do I do the derivative of 3? 3 is like 3 times x to the 0 power. Because if there's not a variable there, it's like it's to the 0 because anything to the 0 power is 1. And this is like 3 times 1 because it's not there. So it'd be like 0 times 3, which makes that, the derivative of that, 0. So this becomes 0. So like it's 0 minus 2 times 2 would be 4. And then you would decrease that by 1. So this becomes negative 4x. And that would be my answer. All right, now I kind of went over here into my warning, which I didn't mean to do when I was writing, but I did. All right, so what I wanted, and in fact, I'm going to put my warning, I'm going to draw an arrow and put it up here. All right, I'm going to say this. If you go to take the derivative of 1 over x squared, this does not equal 1 over 2x. That is a big no. That's a big no-no. No, no, no. You have to do this. You have to say 1 over x squared. What do you have to do? You have to move everything up. So it becomes the derivative of x to the negative 2. And then you take the derivative and it's negative 2x to the negative 3. Okay? So remember this right here. That's the line you want to remember. Got to move it up. You got to move it up to the top. All those times I told y'all no negative exponents. You got to move it up. All right, guys. So 127 minutes later, which is 90 minutes of our class, you now know what a derivative is, and you know how to take it. The rest of it's walk in the park. Thanks for watching.